This video continues our discussion on normalization. So what is normalization? It's the process of improving the logical design to create well-structured relations. All right, so the purpose is fourfold. First, we avoid duplication and conserve storage. So by eliminating the redundancies that we discussed previously with our anomalies, we can save storage and get rid of duplication, which could cause a lot of issues when trying to query our data. Second, we satisfy certain referential integrity constraints. So if you remember from relational modeling, referential integrity is what determines our primary key and foreign key pairs. And so this allows us to satisfy that by having one particular row reference at most one other row in a related table. Third, it helps us facilitate data maintenance by eliminating the insertion, update, and deletion anomalies. So everything that we talked about with regarding those anomalies is completely done away with. And then fourth, it provides better design and enables future growth. So for my web server, I built it without planning my database, which kind of seems silly. I wasn't really planning on it being as big of a deal as it is now. And so I just had one table, and as growth began to happen, it was much more difficult to actually be able to do what I wanted to with my database and with my web server. So I sat down and I modeled my database and I normalized everything and came up with the tables that I need. And ever since I've had a normalized database, when I've needed to add a new table or a new column, it was really easy to just restructure to meet my needs. So general rule of thumb is that a table should pertain to only one entity type. So in order to understand normalization, you need to understand functional dependencies. I cannot express how important it is for you to understand functional dependencies. If you don't understand what this is, you will not be able to successfully normalize. So let's walk through what a functional dependency is. The definition of a functional dependency is the value of the determinant, which is going to be the value on the left of the arrow, and I'll show you what I mean by that in just a second, decides the value of another attribute. This is what's going to specify our integrity constraints. So it's going to identify those candidate keys that are going to become our primary keys of a relation. It is represented by an arrow as indicated here. A functional dependency is written as A determines B. So this basically states that B is functionally dependent on A. So if you know the value of A, there can only be one value for B. So let's look at an example of a functional dependency. If I were to give you a customer ID, could you tell me the name of the customer? The answer is yes. If I give you 529, you could tell me that the customer associated with ID number 529 is John Smith. On the other hand, if I gave you the customer name, could you tell me the one customer ID that's associated with that name? No, because there could be multiple John Smiths in our database. So that John Smith could determine 529, 324, 686. So this is not an example of a functional dependency. So again, if you know the value of A, you will know the value of B. So now let's look at an extended example of the functional dependency. So if we have the following attributes of order ID, order date, customer ID, name, address, product ID, description, finish, price, and quantity, what would be our functional dependencies? What I suggest is that you start with the first attribute and you see what it determines. So order ID, if I know the ID of an order, will I know the date of the order? Yes, I will. Will I know the customer of the order? Yes. Will I know the name of the customer on that order? Yes. Will I know the address of the customer on that order? Yes. Will I know the product ID on that order? No, because an order can have multiple products on it. Will I know the description of the product for that order? No. Will I know the finish of that product for that order? No. Will I know the price of the product for that order? No. Will I know the total quantity of product on that order? Depends. If you're saying that quantity is the total number of quantity of items on that order, sure. But this is referring to the quantity of a specific product on that order. So no. Then I'd go to order date. I'd say, if I know the order date, will I know the order ID? The answer is no, because dates alone should never determine anything. In fact, order date shouldn't determine anything that we have on this entire page. So let's go to customer ID. If I know the customer ID, will I know the order ID? No, because a customer can place multiple orders. Will I know the name of the customer? Yes, I will know the name of the customer because each customer is assigned a customer ID. Will I know the address of the customer? Yes, I will as well. Will I know the product of the customer? No, because the customer can get multiple products. Same goes for description, finish, price, and quantity. So let's go to name. If I know the name of the customer, will I know any of the attributes? Order ID, no. Order date, no. Customer ID, maybe. If you're saying that each name of the customer is unique, which I argue that it's not, then you could potentially say that it is associated with the customer ID. You could even argue that address determines customer ID, but what if there's multiple customers with the same address? So those are some things that you have to be cautious about. So name and address don't determine anything. Now let's go to product ID. If I know the product ID, will I know the order that that product ID is on? No, because that product could be sold on multiple orders. Will I know the order date? No. Will I know the customer associated with that product? No, because a product can be purchased by multiple customers. So product ID cannot determine name or address. Will I know the description of the product? Yes. Will I know the finish of the product? Yes. Will I know the price of the product? Yes. Will I know the quantity of the product? If you're looking at the quantity in stock, then yes, but no, we're looking at how much of that quantity was included on that order. So what determines quantity? Order ID and product ID together determine the quantity of that specific product on that specific order. So our functional dependencies here are that order ID determines order date, customer ID, name, and address. I also included a few other functional dependencies for illustrating how to remove certain functional dependencies. So for example, number 2, we have order ID and order date determining customer ID, name, and address. And that's perfectly correct. Yes, those two together could determine those. I have order ID and product ID determines quantity. I have product ID determines description, finish, and price. I have product ID and description determine finish and price. We could argue that description determines product ID, finish, and price, but we'll talk about this in a later video as well. We have customer ID determines name and address, and we have customer ID and name together determine address, which is correct, but not necessary. And then finally, we have name could determine customer ID and address, but there's an argument that that's not even a functional dependency. I just put a bunch of potential functional dependencies here for future discussion in subsequent videos. So now what I want you to do is look at the following attributes and identify all the functional dependencies that would exist. So try this on your own, pause this video, and then come back to compare your answers. All right, welcome back. So let's go ahead and identify the functional dependencies. So if I know the shipment ID for a specific shipment, will I know the date of the shipment? Yes, I will. So let's go ahead and write that as a functional dependency. So shipment ID determines shipment date. All right, will I know the origin that that shipment came from? Yes, I will. So origin is also determined by shipment ID. Will I know the destination of that shipment? Yes, so I'll add destination here as well. Will I know the ship that that shipment goes on? Yes, so I'm going to include the ship ID as well. If I know the ship ID, will I know the ship name? Yes, I will know the ship name that that shipment went on. Will I know the captain of that shipment? Yes. So let's go ahead and include captain ID. But you may argue, what if a ship has multiple captains? Well, typically there is one captain and then you have the first officer and so on. So we'll stick with the fact that there should only be one captain on a ship. The next thing we're going to look at is captain name. And yes, shipment ID can determine the captain that delivers that shipment. So let's go ahead and include captain name. Now, if I have shipment ID, will it determine the one item on that ship? No, because there could be multiple items that are on that ship. Will it determine the description of the item? No. Will it determine the weight of the item? No. Will it determine the quantity of that item on the shipment? No, it will not. So let's go to the next attribute. Shipment date alone shouldn't determine anything, so let's skip over that. If I know the origin of a shipment, will that determine anything? No, because origin cannot determine shipment ID because there could be multiple shipments from the same origin. The same goes for destination, so we'll skip over both of those. Now, if I know the ship ID, will I know the shipment ID? No, because a ship could deliver multiple shipments. So I won't know the shipment date either, or the origin, or the destination. But if I know ship ID, will I know the name of the ship? Yes, so I'm going to say ship ID determines ship name. Will I know the captain of that ship? Yes, so I'll know the captain ID, and I will know the name of that captain. Will I know the item ID of that ship? No. Will I know the description, weight? No. Quantity? No. All right, so if I know the name of the ship, well, I know the ship ID. Potentially, but there could be multiple ships with the same name. So we're going to argue that no. So let's go to Captain ID. And if we go all the way up to the top, we'll see that Captain ID does not determine the shipment, just like it didn't with Ship ID. And Captain ID does not determine the ship because a captain could actually drive many ships. That's an assumption you'd have to make if you say that a captain is always going to be associated with only one ship, though. Let's go down to the next thing. Does a captain ID determine the captain name? Yes. So if I have one captain ID, I will know the captain name for that captain ID. Does captain ID determine anything else? No, it does not. So let's go to item ID. Does the item ID determine the shipment? No, because the item ID could be on multiple shipments. So item ID would not determine shipment date or origin or destination. An item ID could be on multiple ships. It could be shipped by multiple captains. So it's not associated with any of these attributes above. Now, does the item ID determine the description of the item? Yes. If I know the item ID, I will know the description for that specific item. Will it determine the weight of the item? Yes. Will it determine the quantity of the item? No, because the quantity could differ depending on the shipment. So what determines quantity? Well, it's going to be the shipment ID and the item ID together are going to determine quantity. So if I know the shipment ID and the item ID, I will know the quantity of that item on that shipment.